So next we're going to talk about the zeros and use those. Those will be very helpful when we're graphing these polynomials. Um, so if p is a polynomial function, then c is called a zero if p of c equals zero. So in other words, it solves this equation p of x equals zero. Um, so we set the polynomial, set the function equal to zero, solve for x, and that gives us the zeros of the function. And so these are all equivalent things to say. So c is a zero, x equals c will solve that equation. X minus c is a factor of p of x. So in other words, the very simple um, example of this would be like x minus 2 times x plus 1 equals 0. The two solutions to this would be x equals 2, x equals -1. And so these are called factors. These are called the zeros or the solution. So if we have x equals 2, then x equals 2 is a 0, x minus 2 is a factor. And then graphically, these correspond to the x-intercept. So if we were graphing this one, we would have an x-intercept at -1, we'd have an x-intercept at 2. And then we can use the leading coefficient test that we talked about in the last video. And we know that the leading coefficient here would be x squared if we multiply all that out. So we're going to go up to infinity on both sides, and so the graph would look like that, and that's all you need. And even if you have more than, it's a higher degree polynomial, you have 3 or 4 zeros or 5 zeros, that's pretty much all you need. So there might be one other thing that we've talked about, but that's mostly what you need to graph these. So guidelines for graphing. I'll let you read through this on your own, and we'll just get to an example here. So we have x cubed minus 2x squared minus 3. So first we're going to find the zeros. So let's set this function equal to 0. And first thing we can do is we can factor out an x. And we're left with this. So now we have a quadratic, and we can factor that one pretty easily. So we factor that, we get x minus 3 times x plus 1. And so now we can get our zeros. So so one thing I haven't mentioned is, but you probably already know this, is if it's a degree 3 polynomial, then we could have 3 zeros. We could have less. It could be like x cubed technically only has 1 0, which is 0. So y equals x cubed is what I mean. So like that only has 1 0. But if you have degree 3, you're never going to have more than 3 zeros. So just kind of keep that in mind. You could have 0, 1, 2, or 3. Actually, well, we won't get into that, but so here we have x equals 0 for that one. We have x equals 3. We have x equals -1. So there are all the zeros. And then to graph this, let's plot the zeros. So 0, 3, -1. And now let's talk about end behavior. So the end behavior is really the only other thing we need to consider. So as x goes to infinity, as x goes to -infinity, what happens? Well, so what's the degree? The degree is odd, and the leading coefficient is positive. So this essentially looks like y equals x cubed. But since it has other terms, then it's going to have a couple of bends and that kind of thing. But we know that as x goes to infinity, y is going to go to infinity. And as x goes to -infinity, y is going to go to -infinity. So we talked about that in the last one. And so really, we know it's going to come up like this. We know it's going to come down like this. And so now we just have to connect those. So there, connect those. there we connect those, and there we go. Now this one could come up higher. I mean, it could come up really high, possibly, probably doesn't, or it could come down really low. But we're not too worried about that. The homework in this section, like I said before, is all multiple choice. So you really only have to pay attention to where are the zeros on the answer choices, and then what's the direction on the ends, and then that will be enough to select the right choice. So we're not worried about how far down do you go, how far up do you go. Once you take calculus, you can figure those things out pretty easily too. But that's not really important for right now. All right, shape of the graph near a zero. So what happens there? So in other words, you have two possibilities here, and we'll use y equals x squared and y equals x cubed to demonstrate this. Here, this one does not cross the x-axis. So y equals x squared does not cross. Here, this one does cross. And for y equals x cubed, it does cross at the zero. So what makes the difference? So we have what's called the multiplicity of a zero. So if c is a zero, corresponding factor would be x minus c, occurs exactly m times in the factorization. Then c is a zero of multiplicity n. So in other words, you could, if you have a factored polynomial, you could have something like this, where you have x minus 2 cubed and x plus 1 squared and x minus 9 to the first. So multiplicity 3, multiplicity 2, multiplicity 1. So if it's an odd multiplicity, then it's going to cross the x-axis. And this is kind of why I drew these, because you can use these to remember which is which. Odd multiplicity is going to cross. Even multiplicity is just going to come down, touch, and then come back up. And then that's the difference. And so using that, now we can graph this one. So what are the zeros? So the zeros are x equals 0 for this x to the fourth. We have x equals 2, and we have x equals negative 1. So let's plot those. So 0, negative 1, 2. All right. Now this is the part where people could mess up. And well, before we talk about that, here we have an even multiplicity, here we have an odd multiplicity, here we have an even. So it's going to touch there, it's going to cross here, it's going to touch there. So now let's talk about what's the degree of this. So the degree, sometimes people, when it's factored out like this, they don't know how to figure out the degree, or they'll say the degree is 4, which is not correct. The way you find the degree is you add up the exponents. So we have 4 plus 3 plus 2. So that gives us 9. So this is a degree 9 polynomial. And then for the leading coefficient, you would take, so the coefficients in each factor. So in this case, it's just 1 times 1 times 1. So the leading coefficient is 1, which is positive. That's really all we're worried about. But if this was like negative x plus 2 or negative x minus 2, then that would make the leading coefficient negative, because we have a negative or positive 1 times a negative 1 times a positive 1. So you're basically just multiplying these leading coefficients in each of these factors and figuring out what sign. We really care about the sign. We don't care if it's 10 or 12 or 15, or we only care if it's positive or negative. So this is an odd polynomial, positive leading coefficient. So odd degree, positive leading coefficient. So this one in behavior looks like that. So as x goes to infinity, y goes to infinity, and as x goes to negative infinity, y goes to negative infinity. So we know that we are coming down like that. We're going to go up like that. And now what happens in the middle? So negative 1 is an even multiplicity because of the square. So that one is just going to touch and come back down. 0 is an even multiplicity. So we need to get back up and touch there. And then obviously 2 is an odd, but we already kind of know it's going to cross there. So, so that's kind of how you do that. So pay attention to, so we have the zeros, we have the multiplicity, and we have the end behavior. And then those are the 3 things that you need to pay attention to when you're graphing these. And then the last thing is looking at the local max and min. I don't have an example of this. This is very basic. You'll be given a graph and figure out where the local max and min. So the local max and min, all that's talking about is where does it decide to change direction. So if it changes direction, you're going to have either a max or a min, and it's obvious which one's which. And so when it asks for this, it's really just asking for what is that ordered pair where it does change direction. We're not going to worry about how to calculate that here. That's probably more of a calculus class thing to do where they give you a polynomial and you can figure that out without the graph. But here we're just going to have the graph, and so again, if we could draw one like this, and then let's say that is -2, -1, so that'd be a local minimum. Here we have, say, 1, 3, that'd be a local maximum, and then here we have another local minimum. So, so those are pretty basic. We don't probably need to spend a lot of time on those, but make sure that you can pick out a graph like this. Again, like I said, these are going to be all multiple choice, with the exception of maybe a quadratic, but we know how to graph those on WebAssign. And other than these 3 things, it should be pretty easy to pick out the graph. So if you have any questions, you can email me and we'll figure those out.